Hi guys, so we are going to talk about basic functions and their graphs. Okay, so a relation is any set of ordered pairs. So an ordered pair is x comma y. All right, now the domain, we denote that with a capital D, okay, is the set of the first components of an ordered pair in a relation. Now the range, or we denote that with a capital R, is the set of all second components. So the domain, again, is our x's. And the range is our y's. So a function is a correspondence between the first set, called the domain, to the second set, or the range, such that each element in the domain corresponds with exactly one element in the range. Now, I'm going to say this a couple of different ways, because like everybody understands things differently, okay? So in other words, a function is a special kind of relation that pairs each element of the domain with one and only one element of the range. So another way is, for every x, there's exactly one y. Or, each first coordinate appears only once. So I'm going to draw you guys a picture. I am not artistically inclined, so please be aware of that, okay? Like, yeah, I draw stick people, so there you go. But I want you guys to think of a mailman, okay? That's what my picture's going to be, is like of a mailman. So think of a mailman. Oh, here we go. We're going on this circus again. I love this. I don't know why it does that, y'all. I just don't know. Here we go. There's an E in here. Think. There we go again. I'm just not in the know of why it does this. Okay, and he, the mailman, he delivers letters, right? Or he used to mailboxes. And a letter can only go to one mailbox. Man, you guys, this is so not fun. I'm so sorry. I really am not doing this on purpose. I just gotta laugh about it because it's this in another video. Okay. There, that's on my word. That's on my word salad right there, guys. All right, so let's draw our mailman over here. So this is our mailman. And he's a happy mailman. He loves his job. Okay, that's our mailman. He's our function. All right, he's our function. Now, what does he deliver? Yes, letters. So now we got to draw a couple letters. Now these are letters, or our x's. Right on? Now, what color do we want? Let's make our, yeah. And now we have to have our mailboxes. Sorry. And these are our y's. Okay. So each letter can only go to one mailbox, right? So like that letter can only go to that mailbox, and this letter can only go to that mailbox. Now a mailbox can take 2 letters, right? But like this letter can't also go to this mailbox, right? That's impossible. Maybe if we tore it in half, but that's not legal. So this is a function, right? This function letter can only go to one mailbox. So like that helped me remember like a function, each x can only go to one y. So hopefully that helps you guys remember, like when you get into oh my God, is this a function or is it not? Just think about the mailman, right? And the letters can only go to one y. Cool. All right. Most expensive piece of artwork you have so far in your life, probably. I don't know, maybe not. You may already have something else. All right, here we go. So I'm gonna have to delete that, and then now. Oh my. Let's just go to the second page. How about that? Okay. That was crazy. Sorry. Okay, so although every function by definition is a relation, not every relation is a function. So let's look at this right here, this little relation, and see if it's a function or not. So remember, we got to make sure our x's don't repeat. So let's find our domain, right? So what does our domain equal? Remember, our domain is always the x's. So tell me what our domain is. It's going to be 1, 2, 3, and 4. So on any of that, did our x's repeat? No, right? So no x's repeat. So that means that it is a function. Okay, what about this one? What's our domain on this one? Remember, it's our x's. So what are our x's? Jeez Louise. Sorry guys, I did something wrong. I don't know what it was, but I keep trying not to do it. But when you don't know what you've done, it's really hard. So what is my domain on this one? 6, 6, 8, and 9. So is that a function? It's not a function, right? Because our 6's repeat. So this means implies, right? So that implies not a function. And FN, that's my shorthand for function because, well, mathematicians are lazy, and I fall into that category. So I'm just going to own it. Okay, here we go. Let's talk about functions as equations. So functions are usually given in terms of equations rather than sets of ordered pairs, right? Very seldom in college algebra do we just run into a bunch of ordered pairs. So it is important to know that the difference between independent and dependent variables. Okay, so we're going to learn that. Since the variable y is a function of x, which tells us that for each value of x, there is one and only one value of y, right? That's what we just learned to be a function. Therefore, the variable x is called independent variable because it can be assigned any value from the domain, right? We can assign any value to it as long as it's one of the legal non-negative number integers. And the variable y is called the dependent variable because that value depends on x. So we assign a number to x, and then that determines what y is going to be. Now, just like ordered pair is not every ordered pair is a function, not every equation is a function. So this right here is very useful information. If the exponent for y in any equation contains an even power, oh, there we go again. Oh, it has something to do with if I write over myself, I think is what I'm coming to find out. So if it has an even power, Whoa, stop. For the love of Peter, Paul, and Mary. Sorry, guys. I'm just not even going to try to underline that twice. Then the equation, Jesus, help me. Then the equation, I'm going to read that all again because I just blew out. If the exponent for y in any equation contains an even power, then the equation does not define y as a function. So if y has an even power, like 2, 4, 6, 8, right, anything even, then it's not a function. So I'm going to try this again. Yeah, that's what I meant to do. So this is super important. Like, this is a great tip, right? Like, this is one we want to take home with this. Not forget it, okay? I'm going to do that for a minute and then leave it there for you. Underline that better than I did. Now I'm going to go to the next page. I have to take that go away. Okay. You guys, this is like the second day I've tried to use this tablet, so I promise, I'm not going to promise, I'm going to strive to become better at this, okay? That's my goal. Okay, so here we go. Let's determine if the equation is a function. So let's work this first one. So we have x squared plus y equals 4. So let's solve for y and see if it's an equation, okay? So let's subtract x squared from both sides, right? So if we're going to subtract x squared from this side, that means we have to also subtract from this side, because what you do to one side, you must do to the other. Cannot play favorites. It's like having kids, right? So these cancel. That's going to leave me with y equals 4 minus x squared. Now, can you see here that y equals just one number, right? But that number is going to depend on what we assign to x squared. So let's assign x a value. I guess it depends on what we decide x is. So y depends on what we assign x. So y that's supposed to be an A. So let's let x, what do you want to say, equal 1? Okay, so if we plug in 1 for this, we're going to have y equals 4 minus, if we plug something in for x, we always put that in parentheses, right? It's just a good habit to get into. What's 1 squared? 1. So this is going to equal 4 minus 1, which equals, 3. You got it. So y equals 3. So we plugged in one amount for x and we got one y out. So that is a function, right? So this is a function. That's an n. So that's good. Now when we go over here, I'm going to do this in a different color, hopefully. We're going to do the same thing, right? We're going to solve for y. So we're going to start the exact same way. We're going to subtract x squared on both sides. So we're going to cancel. So we're going to have y squared equals 4 minus x squared. But we have to get rid of the square, right? Because we're just solving for y. So to get rid of that, we'd have to take the square root, right? Because a square and a square root, they cancel. But if we take that on this side, we have to do that on this side. Again, no favorites, right? But it's an even root. So when you take an even root, you can't forget to do the plus minus. Now I'm just make me a new equal sign here. Now, like I said, this 2 and this square root. The square and the square root cancel. That's what I'm trying to say. Y equals plus minus square root of 4 minus x squared. Okay, so now we can see that y equals two numbers, right? A plus and a minus. So once again, let's plug something in for this. So this time, let's let x equal 0. So if we plug 0 in for that, we're going to have y equals plus minus square root of 4. Well, 0 squared is just 0, so let's just make that simple. Well, 4 minus 0 is y equals plus minus square root of 4. Well, square root of 4 is 2, so y equals plus minus 2. So we plugged in one number for x. Let's make this a t-chart here, or an xy chart, whatever you got. We plugged in 0 for x, but we got two numbers out, right? We got a 2 and a negative 6. All one number. So this goes against everything we know as a function, right? So this is not. It's a function. Sorry, it's tricky writing on these. Not a function. Okay. All right, I'm going to stop here because that's 15 minutes. So that's a long enough video. I'm going to stop here and then I'm going to start back up with function notation. Okay, so you guys don't have to sit forever and watch a video. You can do 15-minute clips. All right, have the best day.